In this video, we're going to use length, area, and volume scale factors to help us solve problems. Now, before we get started, hopefully you've watched the previous video and you already know that if I have a linear scale factor and I increase a length by L, okay, so let's say L is the linear scale factor, then L squared will be the area scale factor and L cubed will be the volume scale factor. And if we know that, then we're in a situation where we can work out some answers. So first question above, if we have this shape here, look, okay, and we enlarge each length with a scale factor of 2, so linear scale factor is 2, what happens to the area? Well, the area is going to increase by a factor of 2 squared, okay, which is 4. Right, now let's just show you this as a first example, right? Okay, so if I increase the scale factor by a scale factor of 2, I'll have 10 centimeters by 4 centimeters. That's an area of 40 centimeters squared. The original was 10 centimeters squared. So of course, the increase by a scale factor of 4. If we think about the scale factor 3, well, of course, I'm going to have 6 centimeters by 15 centimeters. 6 times 15 is 90 centimeters squared. So my original has increased by a scale factor of 9. Exactly what we'd expect. We get the linear scale factor and we square it, just like we saw from that previous video. Okay, now then, let's see if we can stop jumping through some hoops and make sure. Let's get straight into this question. So we've got a hexagon. It's got an area of 60 centimeters squared. Calculate the area of the hexagon if it is enlarged with a scale factor of. Okay, so if the scale factor is 2, then the area scale factor is 2 squared, which is 4. So that means that my area will be 60 times 4, which is 240 centimeters squared. B, if my scale factor is 4, well, my area scale factor is going to be 4 squared, which is 16. So I'm going to need to do 60 multiplied by 16 to get my area. That will be 960 centimeters squared. Finally, part C, I've got a scale factor of 10, which means that the area scale factor is going to be 10 squared, which is 100. So if I do my original times 100, I'm going to get my answer is 6,000 centimeters squared. Okay, hope that made sense. Let's move on to the next example. So a cuboid has side lengths 3 centimeters, 4 centimeters, and 5 centimeters. Calculate the volume of the cuboid if it is enlarged with a scale factor of 2 and 10. So before we get started, let's work out the original volume of this cuboid. So to do that, we're going to need to do 3 times 4 times 5. 3 times 4 is 12, times 5 is 60 centimeters squared. Okay, so that's our starting point. So in A, we have that the scale factor is 2. So the volume scale factor is going to be 2 cubed. It's always the cube of the original scale factor. So that will be 8. So to work out the new volume, I'm going to take the original volume of 60 and multiply that by 8. If I do that, I get 480 centimeters cubed. That should have been cubed up there. Okay. Right. Finally, if we do, let's just do part B. Okay, so this time we have a scale factor of 10. So my volume scale factor is going to be 10 cubed. Well, that's 1,000. So to work out my new volume, I'm going to take the original volume of 60 and I'm going to multiply it by 1,000. So it is going to be 60,000 centimeters cubed. Right, let's carry on. Final example. Okay, this is going to be tricky. Let's see if we can do it. A sphere has a volume of 20 centimeters cubed. A second sphere has 4 times the radius of the first sphere. Calculate the volume of the second sphere. Okay, so let's just draw a little picture to help us, right? So we know that we have a linear scale factor, and that is 4, isn't it, right? A second sphere has a radius 4 times the first sphere. So radius is a length. That means linear, okay? So the original linear scale factor is 4. So that means that the volume scale factor is going to be 4 cubed, which is 64. So if my first shape, the original sphere, has a volume of 20 centimeters cubed, well, I'm going to need to multiply by 64 to get the new volume. Now, 20 multiplied by 64 is 1280 centimeters cubed, 1,280 centimeters cubed. Okay, I hope that helps you to work out volumes, areas, and lengths between different shapes having different enlargements.